like most springs, you got some opening, and whether that's gravity fed coming down through a hillside, or if it is the water table that's intersecting the surface, whatever the case may be, you've got some head behind it that's pushing. Madison Blue Springs itself is, if I recall properly, a first order magnitude springs. It is pumping a lot of water. So it didn't look quite as impressive over at the last section, location we were to. You got around, you saw how much water's coming over that little spillway. This one, it's pretty stunning to start with. So when we get around the corner, you'll see that. It's also connected to the aquifer system, including an expansive system of underground caves. If I remember the numbers right, there's something like 11 kilometers of mapped cave passages, and they're still working on it. So there are numerous spots there. If you got into it, they could pop up a number of places where there's multiple intersections, but this is the primary spring discharge point. It is, all in all, pretty awesome. And part of my dissertation work, I looked at some numbers here as well as one other location where if we have time, we'll stop there on the way too. A lot of the expansion here has to do with acidic waters. Makes sense. Well, the problem is by the time the water gets into the cave passage, it's gone through all that limestone. And that acid has reacted with the base. So if you look at the rate of dissolution, it's almost nothing. We're talking about 1.3 times 10 to the minus 11 cubic centimeters per liter. Nothing. And that's actually a real number. It's part of the work we had to calculate. Difference is you'll see over here, we go down a little spring run, and you'll find that the river, which is just at the end of that spring run, is found there. When the river water's levels rise, it's got enough of a gradient that it'll push that tannic, organic rich water back into the spring. So it reverses the discharge of the spring, and you inject very aggressive, very acidic waters. And it's hypothesized that a great deal of that cave expansion and that work that's been done is actually coming from the river water reversing back into the spring, even though it only happens for a handful of days a year here and there. We're talking about 12 orders of magnitude change in the dissolution rate. So I gave the example, same one I gave during my dissertation. Everyone hold up your little pinky. The nail right here, 12 orders of magnitude may not sound like a whole lot. The distance, if you put 12 zeros behind that, it's enough to go around the equator 25 times. So we're talking about length versus the flux measurement, but that gets you a little bit of perspective here on what we're talking about. So with that in mind, let's go take a look and